Guys, we made it through another chapter of this COVID year. This is the last chapter for the semester, and then we are on to finals after we take this test. So, today we are doing congruence and right triangles. Side angle, or in other words, donkey. Why does that not prove triangles congruent? So if we look here, okay, we have angle side, right? If we were to take this little triangle, we could technically flip that triangle side over and make another triangle within that triangle. Okay, so see how that works there? Because we can make a new triangle, okay, normally side angle, or angle side, or the donkey, or the cuss word if you'd prefer, does not prove triangles congruent because there's just not enough information and there's a possibility to make another triangle within there. But side angle or angle side does work when the non-included angle is a right angle. So the angle that is not between those two sides is a right angle. So if we look and we were to flip this line here over to make another triangle, it doesn't reach the bottom of the base of that triangle. Okay, or we might have an obtuse one, and again, it makes it an obtuse triangle. The only triangle possible with the two fixed sides and 90-degree angle is congruent to the original triangle. Okay, so if we had a longer side, like if we had this and then we went out even more like that, we would not be able to say these two triangles are congruent, because when we flip that over, it would make a different angle here. So again, if you swing this shorter side, the angle would not be, okay, why is it not letting me do this now? The angle would not be 90 degrees. Okay, so if you swing it either way, the angle is not 90 degrees. A right triangle or an obtuse triangle is the only kind of side angle that does prove triangles congruent. Okay, and in this case, side angle is kind of called the hypotenuse leg theorem. Okay, because looking at this, you will see in a second. So some vocabulary, parts of a right triangle. A right triangle is a triangle with one right angle. There cannot be more than one right angle in a triangle. The legs are the sides adjacent to the right angle, so that means that they are part of the right angle. And then the hypotenuse is the longest side, and it is across from that right angle. Okay, so then looking at, and again, if you need to pause the video, just go ahead and do that. So the hypotenuse leg theorem is if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So if you look, we have angle side, we have angle side, or side angle, side angle. So the hypotenuse leg theorem is basically side angle, or angle side when we are using right triangles. So side angle theorem. But we call it the HL theorem. You can abbreviate it as HL. On your sheet, I forgot an extra tick mark here, so make sure that you make that 2 tick marks for the hypotenuse and not 1. Okay, so both of those are right angles. Our hypotenuse and our leg is congruent. Our hypotenuse is congruent to the other hypotenuse. Our leg is congruent to the other leg. So we can kind of make a little proof here, okay? If AB is congruent to DE, those are the legs, and AC is congruent to DF, those are the hypotenuse, and B and E are right angles, then, or therefore, we can say that triangle ABC is congruent to triangle DEF by HL, the hypotenuse leg theorem. And again, you can just abbreviate it as HL. Okay, so looking at the following triangles, are they congruent by HL? So looking at number 1, okay, we have the hypotenuses are congruent and we have 90-degree angles. RT, there's 2 triangles in this, and we can use the reflexive property to say that R and T are congruent, right? So then we have a hypotenuse that's congruent, leg that's congruent, and the right angle. So these would be congruent triangles. Number 2, we have a right angle in both. We have a leg that's congruent, or the same leg that's congruent, and then the hypotenuse that's congruent. So this would be congruent by HL. Number 3, again, you have your base leg to be congruent. You have a right angle, and then that segment in the middle is shared, which would be the reflexive property, so that is congruent to itself. So this one we can use HL to say that these triangles are congruent also. Number 4, so first thing that I see is that I have 2 congruent hypotenuses, or I think it's hypotenuses. I don't know. There might be a plural form of that. Then I can use the reflexive property to say that CA is congruent to itself, but none of our angles are marked. We don't have enough information here, not enough information to prove that there is a right angle, okay? Yes, I know you guys are kind of looking at this and saying, okay, this is an isosceles triangle, though. The whole entire ABD is an isosceles triangle. Why can't I say that this is perpendicular? You can't say that's perpendicular because there is no angle up here. It doesn't say that these 2 angles at the vertex angle are congruent. Okay, so we're doing some more proofs here, guys. It's not that bad. Again, you don't have to do the normal formal proof. But so angle QPR and angle SRP are right angles. QR is congruent to SP, and then we want to prove that triangle SRP is congruent to triangle QPR. So first of all, I'm going to make some marks on my diagram. QPR and SRP are right angles. So I went ahead and drew a little square there to prove that, or to show on my diagram that they are right angles. And then QR is congruent to SP. So I made tick marks there to show that those 2 are congruent. Now I need to prove that the triangles are congruent to each other. So you can use what we've learned so far in this chapter. You can use the hypotenuse leg theorem, but I need to utilize that line, or the line segment PR. I know that PR is congruent to itself by the reflexive property, so I can mark that as congruent. Then looking at my 2 triangles, I do have 2 hypotenuses that are congruent to each other. The legs are congruent to each other, and then I have a right angle. So I can say that triangle SRP is congruent to triangle QPR by HL. You could also say side-side angle or angle side-side if you wanted to, but HL is much more mathematically correct. Okay, so line segment BE bisects line segment AD at C. So that tells me that AC, or wait, ABE bisects AD. So AC is congruent to CD. And that is because of the definition of bisects. Now that first statement there, you don't have to write down. Like I said before, if you see that word bisects, you ought to, and you write that those two pieces are congruent, that tells me that you understand what the word means and you don't need to put a reasoning down. Then AB is perpendicular to BC, so that makes a 90-degree angle. DE is perpendicular to EC, so that makes a 90-degree angle. And then AB is congruent to DE, so those two are congruent. So that being said, now if I look here, I have two right triangles, and then I have the hypotenuse and the leg. So I can say that both of these triangles are congruent by HL. Because my hypotenuse, the long edge, is congruent, and then the one set of the legs are congruent. Okay, so then these ones, we need to determine if there is enough information to prove that the triangles are congruent. So it does not have to be by the HL theorem. It can be by, any theorem. As long as you can prove that they're congruent with the information, then you can prove that they're congruent. So for number one, we have an isosceles triangle. So if you don't have your notes out from the past lessons, I would suggest getting them out. We have an isosceles triangle, and an isosceles triangle, if that vertex angle, which is up here, is cut in half or bisected by a line, the line is also perpendicular to the base and is a bisector. So that being said, up top we have our vertex angle that is split in half, and both those angles are congruent. So that means that this is a right angle because of theorem 4-5. So we can say that AD is perpendicular to BC by theorem 4-5. And then, so if we're looking at our angles here, okay, we can do this a couple different ways. So we can say that this is reflexive, right? So then we could say that the two triangles are congruent because of the HL theorem. We could also not worry about that middle thing, and we have angle, angle, side. So we could also say that these two triangles are congruent by angle, angle, side. So there are two ways to do that there. Either way, they are congruent. For number two, so I am looking at, I have my two pieces that are congruent already. I know that MO is reflexive, or is the same segment, so I can say that that's reflexive. Now looking at this angle, or these two triangles, I have angle, side, side on both of them, or side, side, angle, however you want to say it. We cannot prove that these two angles here are 90 degrees, so that is a no. And you can say, can't prove right angle. There's no way that we are able to prove that. Then for number three, we have some parallel lines. So I can go ahead and look at my parallel lines there. So I have UT and RS are parallel. I potentially have two transversals there. So if I'm looking at this first one here, okay? I could say that this angle is congruent to this angle because of alternate interior angles. So that would be with the first transversal. Whoops, I don't want to do that. Okay. Then if I work with the other transversal, this one here, I could say that alternate interior angles are congruent. So this one would be congruent to this one here. And then once I erase that, then if you look, we have angle, angle, side. So these we could prove congruent because of angle, angle, side. You could also do, if I didn't want to do, you know, both transversals, I could say that these two are vertical angles, so they're congruent, and that would be an example of angle, side, angle. So again, there's two ways to do that. There are a lot of ways, like I've been saying since the start of this class, there are multiple ways to get your answer. No one answer is wrong if you do it in different steps than I do, or that a person that your friend does, okay? So for number 4 then, we have an isosceles triangle, okay, which means that, first of all, we know that if this side is 90 degrees, this other side has to be 90 degrees because 90 plus 90 equals 180. Then we have this RT is congruent to RT because of the reflexive property. Now, if you look at that, I can use the HL theorem, hypotenuse leg theorem, to prove that these two are congruent. I have the hypotenuse are congruent, and then I have the leg that's congruent. So these would be congruent by HL. Then for number 5, okay, so I have 2 different triangles here. Now, some of you, this might be hard to see, so again, if you need to do colors, colors tend to always help. Okay, so look at where those 2 colors overlap. BC is congruent to BC, whoops, don't want to do it in yellow, because of the reflexive property. Then I have, you know, my 90-degree angles in each corner. Those 2 are congruent. And then my upper angles here, those 2 are also congruent. So if I look, I have angle here, and then a side, angle here, and then a side. So these would be congruent by angle, angle, side. Okay, then for number 6, so this one is super tricky. I had to draw several things here. So first of all, we don't have any sides that are congruent. We don't have any angles that are congruent. So we need to do everything based on our parallel lines, okay? So I'm going to work with the yellow parallel lines first, and I have 2 transversals there. Okay, so we could say, let's work with, whoops, not that. Let's work with this transversal first. Okay, so if I'm doing, you know, alternate interior angles, we could say that this angle, whoops, is congruent to this angle in here, which doesn't really help us out too much. But we'll just leave it like that for right now. Okay, and that is pretty much it for that transversal. Then we can move over to the other transversal and go this one here, okay? Now, looking at that, I have alternate interior angles. They're not really present here, but I do have corresponding angles. So like this, let's see, I don't have corresponding angles for that one. Oh, yes, I do. This one here is congruent to this one here. One's on the inside of those two parallel lines, one's on the outside. So those two would be corresponding angles. Okay, now let's go to the other parallel line. So far I have that. Now, looking at the other two parallel lines, this one and this one. Okay, and now I again have two transversals. So if we look at this transversal here, okay, my alternate interior angles would be this one that I marked. Whoops, didn't want to do that. Dang it. This one that I marked earlier and this one here. So now I have these two angles in red that are in both triangles. Then I can also say, I can't do anything else there, so I'm going to erase that transversal. And then we'll do the other one and look at this transversal. Shoot. Sorry guys, kind of hard. Then I'll look at this transversal here. So again, you're going to do corresponding angles. So this angle here would be congruent to this angle here. Okay, now I'll erase the parallel lines and the transversals. Now, if you're looking at those two, right, we have all of the angles to be congruent. But for triangles, you could have the same kind of angles in any single triangle, but the sides will be different, okay? So for this one, there is, these are not congruent because there's not enough information. You need a side to be congruent in order to prove that the triangles are congruent. There is no theorem or postulate that talks about all angles being congruent, because you could have a triangle that looks like this, and then you could have a triangle that looks like this with the same exact angle measures here, and then the sides are obviously different because they're different lengths. Okay, last but not least, so for what values of x and or y are the triangles congruent by HL? Okay, so we know that for triangles to be congruent, their hypotenuse has to be congruent measures and their leg has to be congruent measures. So for number 7, the hypotenuse in the first triangle is 17, so x has to be 17. For number 8, so my hypotenuse is both 4.25. Those are the hypotenuse, the one that is across from the 90-degree angle. So then my leg would be x is 3. Now 9 and 10 are a little trickier, but you just kind of have to think about which would be the easiest one. Now looking at 9, 13 and then 4x plus 1 are the hypotenuse. So my easiest thing to do here would be to solve for x first. So I'm going to do 13 equals 4x plus 1. Then I'll deal with the other stuff later. So I did right here, 4x plus 1 equals 13, 4x equals 12, and then x equals 3. So I did that first. And then I went ahead and set my two legs equal to each other and plugged in x where I needed to and got y equals 6. You obviously need to solve for one of the variables first. You can't try and solve for x and y in the same equation because it will never work out. So then for number 10, again, my hypotenuse, both have x, so I'm going to set those equal to each other and solve. And I get x equals 2. Once I get x equals 2, then I can plug it in to my bottom equation here. The leg equals the leg, so I set them equal to each other and then plug in 2, and I get y equals 1. If you guys have any questions, let me know. There is homework for both lessons on Canvas. Have a good day.